Hi, in this video I'm going to solving this question. Pause the video, look at the question and solve this before you looking at my solution. Right? Okay, so this question is a system of linear equation, okay, which is given by x minus y plus z equals to a, x plus y plus 2z equals to 1, 3x plus y plus bz equals to 2, where a and b are real numbers. Show that the augmented matrix, okay, the augmented matrix for the system of linear equation can be reduced to this form, right? Definitely is by using the elementary row operation. Okay, so the augmented matrix for this will be 1, negative 1, 1. Okay, the augmented matrix for this system of linear equation, right? 1, negative 1, 1, 1, 1, 2, 1, 1, 2, 3, 1, b, and here we have a, 1, 2. This is the augmented matrix for the system of linear equation here. Can be reduced to that form. Definitely is by using the elementary row operation. Right? Okay, let's see how I perform the elementary row operation here. So at first, if you look at the one that required by the question, that required, we have to see what they required, right? So this is, can you see that the first column, right? The first column, we have 2, 0 here, right? So our focus here is to changing this 2 and 3 here becomes 0 by using the elementary row operation. Okay, modifying the second row and the third row, right? So the formula that I'm going to use now will be, okay, for this entry, so we will modify the row 2, and the row 3 by referring the row 2 and row 3 to the first row, right? To the first row. So positive 1, then you have negative 1. Positive 3, then you have negative 3 here. Alright? Negative 3 here. So this will be the formula for this elementary row operation now. So the one that remain unchanged will be the first row. So I remain the first row, 1, negative 1, 1, 8. Alright? As followed by this one, row 2, second row, all the element from the second row minus the corresponding element from the first row. So 1 minus 1, you have 0. 1 minus negative 1, you have 2. 2 minus 1, you have 1. 1 minus 8. Alright? We have 1 minus 8 here. And now 3, row 3, right? Row 3 minus 3 times the row 1. So means that you're taking the element from row 3, 3 minus with 3 times the element from row 1, which is 1. So you're getting 0 also. Right? 1 and negative 1. Just like 1 minus with 3, 1 from row 3, minus with 3 from row 1, which is negative 1. So you're getting 4. Right? So on. So then now is b and 1. b minus 3 times 1. So you have b minus 3. And 2 and a, right? 2 minus 3a. 2 minus with 3a. So this is the first elementary row operation that I'm using, which I already reduced the matrix from this to this form, right? With the first entry from each row, from the second row and third row become 0, right? Okay, I do based on what is required by the question. If you see carefully, right? So the first 2 here is 0. Later on, you see that from this reduced to this, from this form reduced to this form. If you see carefully that the first row and the second row already the same, right? 1 negative 1 1a, right? 1 negative 1 1a, and 0 2 1 1 minus a. So I'm not going to do elementary operation for the first and the second row. Now I'm going to modify the third row. The third row will be 0 0 5 minus ba, right? Will be different, where the second element from the second entry
from the third row is becoming 0, right? So if you see carefully, the third element here become this element. The third row, second column becomes 0. So I have to reduce
by using another operation. So where I have to modify the third row. Modify the third row by referring it to another row. For example, this is something, this one I never change to 1, right? For this case, for this question. So I can using the second row. Because 0 and 0, they won't disturb, right? So if you use the third row and the first row, then it might change the entry here, right? It might change if you're using between this row and this row to solve using elementary operation. It might change the value here. Now I want to remain here at 0, so I better refer it to the second row, right? Refer to the second row. So the third row and the second row by putting a -2 here. By putting the -2 means that the row 3 minus 2 times row 2. Alright, so then what I'm doing, I'm going to start doing elementary operation. Copy back the first row and the second row. 0, 2, 1, 1 minus with A. Third row will following this operation here. Third row and the second row, which is I take the row 3 minus 2 times the row 2, right? So this one. So row 3, which is 0, minus 2 times 0, you are still getting 0, right? Still getting 0. 4 and 2, row 3 and row 2, row 3 and row 2. So for this, you have 4 and 2. 4 minus 2 times 2. So you're getting 0, right? You're getting 0. So -3 and 1. B minus 3 and 1. So follow this formula here. So you know that it's row 3 minus 2 times row 2. So for this element here, we refer to the row 3 and row 2 here, right? B minus 3. So the row 3 is B minus 3. Minus with 2 times the row 2. The row 2 will be 1. So you are getting B minus 5. So for here you are getting B minus with 5. How about this? Right? How about this? So this is refer to the row 3 and the row 2, right? Row 3 and row 2. Follow the same formula. Row 3 is 2 minus 3A minus 2 times the row 2, right? Row 2 is 1 minus A. 1 minus A. So 2 minus 3A minus with 2 plus 2A. So you will have 2 minus 2, 0, right? So you have negative A. So here you are getting negative A. Done. Okay? But you check again. If you check again, you will see that, okay, the first row, 1, -1, 1A, right? 1, -1, 1A. 0, 2, 1, 1 minus A. But the third row will still have some problem here, even though this 2 is 0, right? I have done with this, both this 2 is 0, but this is B minus 5 and negative A. And this is 5 minus B and A. So the difference is, this is the negative of this, right? It's the negative of this. And this is also the negative of the element here, right? So means I'm going to take the third row with one more elementary row operation, where I'm taking the third row, multiply with a negative. Okay? Multiply with a negative. Then I will getting 1, -1, 1A. 0 to 1, 1 minus A. And multiply negative 0, multiply with negative for this. You are getting negative of B minus 5, negative B plus 5, or we can rewrite as 5 minus B. Multiply with negative A, you will have A. So if you see carefully, I have already reduced the augmented matrix for this system of linear equation in this form, right? In this form. So 1, -1A, 0, 2, 1, 1 minus A, 0, 0, 5 minus B, A.
Alright, so I have shown which can be reduced to this form. But this is not an reduced row echelon form, okay? Because you see that it's not become an identity yet, right? Okay, now the question again asking us, hey, hence, find the complete solution of the system for this system if given both of this value. Alright, let's see how to do this. Alright, okay, let's continue. Now the question, just now I have shown you how to reduce from the augmented matrix for this and reduce to this form. So just now I just erase everything here. So I starting from here. After reduce, we have to find the value of x, y, z, right? Solving the equation, and the complete solution is given that the value of a and b is 3, right? So then you know that now I can replace this to be with 1, -1, 1, 0, 2, 1, 0, 0, 5 minus b, right? The b given 5 minus 3 is 2, 2, and a is 6, 1 minus with 6, -5, a is 6. So now I have to starting from here after we have reduced so far up to here. So now how to reduce this to, if we want to use Gauss-Jordan, okay, for this I'm going to use Gauss-Jordan elimination method, even though there are other methods. So in matriculation I introduced Gauss-Jordan elimination method. Alright, Gauss-Jordan elimination method. So which I did to reduce this into reduced row echelon form. Alright, so very simple. First, I can see that, okay, now I have to, using the operation, the elementary operation, where I can actually 0, 0, 2, there is 6 here, right? 2, 6 here. I can reduce, making this become 1 by divide everything by 2. So means I taking the third row, multiply with a value of 1 over 2. So and I will getting 1, -1, 1, 6. This one remain unchanged. 2, 1, -5. So 0, 0, 1, and 3. Okay, for this I will never follow the method that I introduced before because this is already expert. Okay, once you already expert, you can actually see you doing the elementary row operation based on the condition. Okay, based on the condition. For me, I was thinking that this is better, okay, to solving instead of divide this by 2. Okay, we have to be flexible when we learn maths. We cannot be doing things by follow procedure. Okay, we have to be flexible. So Z2, so divide by 2, you have 1 over 2 and then 1. So I try to avoid that. So what I'm doing is I reduce this row first by dividing this into by 2, so they're getting 1 and 3, right? 1 and 3. Actually, now you already know the value of Z. Z is 3 actually. Alright, never mind. So now what I'm doing is I want to changing this become the value of 0. Alright, I can changing the value of 2 here becomes 0. Okay, so very easy. So you just doing this way. You're taking the row, changing this become 1. Okay, become 1. So that you can getting identity matrix is 0, 1, 0, 0, 0, 1, 0, 0, 0, 1. This is done, right? But this one I want to change become 1. Okay, so what I do is I thinking that I take the row 2, modify, after you expert row 2, you're taking the row 2. Because if you take this number plus with this number, let's say you're taking this number plus with this number, for example, or we can say that, okay, where I'm taking the second row minus with this row first. Okay, I minus so that this 2 will become 0 first. Okay, I can doing this. So I minus with row 1, minus with row 1. So and now this one will be remain unchanged, 0, 0, 1, 3, and the first row also unchanged, 6. So this is the row change, row 2 minus row 1, because the purpose is to making this become 0. Okay, before that I have to making this become 0 first.
So how I'm taking row 2 minus with row 1. Okay, sorry, it's row 3 row 2 minus with row 2 minus with row 3. So the purpose here is to, because we can't take just now I'm taking row 2 minus row 1, but we cannot do that because if 0 minus 1, you're getting a negative 1 here, negative 1 here, which is you have actually reversed the process. Okay, so better if you're taking 0 minus 0, you will remain at 0, and 2 minus 0, you will getting 2, right? You are getting 2, and 1 minus 1, then you are getting 0. Then getting 0, and negative 5 minus with 3, right? Row 2 minus row 3, row 2 minus row 3, negative 5 minus with 3, you have negative 8. Now very easy, right? You can see 0, 2, 0. This 2 already becomes 0. You need to think why I never take row 2 minus with row 1. Even though row 2 minus with row 1, 1 minus 1, you're still getting 0. But I don't do that because of this. 0 minus 1, you're getting a negative 1 here, which is not helpful at all. So that's why I'm taking row 2 minus row 3. 0 minus 0, 2 minus 0, getting 2. 1 minus 1, getting 0. And negative 5 minus 3, getting negative 8. So that later on, I can reduce the row 3, right? The row 2. The row 2 by divide with a number 2 here to getting 0, 1, 0. So the row 2. So I'm getting 1, negative 1, 1, 6, 0, 1, 0, negative 4, right? 0, 0, 1, 3. Okay. So now I have change this to 0, 1, 0, 0, 0, 1, and this one I'm going to change it become 1, 0, 0, so that it become an identity matrix here. So what I'm doing is, at first I want to modify the row 1 by taking the row 1 plus with this row, because why? I know that negative 1 plus with 0, you're getting 1. Okay, you're getting 1, you see. Negative 1 plus 1, you're getting 0. This is the purpose. I can getting 0 here, even though here not yet. Doesn't matter. So I 1 plus with 0, I getting 1. 1. 6 plus with negative 4, I getting 2. Alright. So means I plus row 1 with row 2 first. Alright. Row 2 first. But the row 2 and the row 3 remain unchanged. Don't change this anymore because it's already okay. So 3. Okay, that's the last number here, which I can change this become 0. But I don't using this row and this row anymore because can't help me, okay? This got 1 and 0 can't help, okay? Can't make this become 0, okay? So what to do is row 1 and the third row. 1 minus 0, 1. You remain getting 0. You're getting 0 here. This is what I want. So means that after I observe, I know that I need to take the row 1. I need to take the row 1 minus with row 3. Minus with row 3. So this is we already expert, so we can decide in this way. So 1 minus with 0, 1, 0, 0. 2 minus 3, negative 1, 3, negative 1. 0, 1, 0, negative 4, 0, 0, 1, 3. Now this has become an identity matrix, and definitely this will become your solution for x, y, z here. So this is reduced row echelon form by applying Gauss-Jordan elimination method. So from here we can see that your x value is negative 1, your y value is negative 4, and z value is 3. So this will be the solution for this problem here. Alright, okay. I will teach you another method, alright, if you're interested, this is Gauss-Jordan elimination. Gauss-Jordan elimination, you have to reduce it up to the identity matrix here. Alright, so I apply Gaussian elimination without Jordan. Okay, Gaussian elimination. Okay, let's see what I mean here. Alright, let's see alternatively. Okay, but this is usually I refer to teaching for STPM student. Okay, for STPM student, Form 6 student. And the method just now, Gauss-Jordan elimination, is encouraged to do for matriculation student. Okay, So I just alternative so that you have more knowledge. Alternative, you can using Gauss elimination. Okay, Gauss without Jordan. Okay, Gauss elimination. So it's almost the same, just the process. You don't have to reduce to row. This is row echelon form. Don't need to reduce row echelon form. So where you already see that after you reduce by the first elementary operations, you can actually see that 0, 0, 1, 3. So you have know that the value of z is 3, right? You have already know the value of z is 3. So now you're going to apply this value to the second row, okay? To the second row. Alternative, so because second row is this refer to y, right? 0x 2y plus z, 1z equals to negative 5. You already know the value of z, right? So 2z plus 3 equals to negative 5, and solving the linear equation here. So you have y to be negative 4, right? Y to be negative 4. Z is 3, right? Very simple, right? Okay, you have know the value of y and z by using the second row. Now you go for the first row. So where you have x, this is x minus y plus z equals to 6, right? So you have know the value of z and y, right? X minus with negative 4 plus with 3 equals to 6. So from here you have x plus 7 to be 6, and 6 minus 7 you have negative 1, right? So this is a lot simple compared to Gauss-Jordan elimination method, which you have reduced it to row echelon form. Once you see a row that with 0, 0, 1, or you have 0, 1, 0 is enough. You can stop there, the elimination operation, start using the linear equation in solving this, right? For example, this one you know z is 3. After know z is 3, then from this equation, you can find a relation between y and z, and you can find the value of y easily, right? And later on, you can find the value of x easily from the first row, okay? This is sharing for you, okay? But it's not encouraged for matriculation student. We have to use Gauss-Jordan elimination method, right? That's all for this video.